Hello and welcome to this quick tutorial on the new LOD system of Unity 3.5. So, first, what is a LOD? LOD, as you might know, stands for a level of detail. So, what do you use it for? LOD is used especially for outdoor scenes where you have many objects cluttering the screen, but the majority of them is pretty far away. So they are covering up, let's say, 10 or 20 square pixels on your screen, but still are rendered in the same high resolution as the objects which are very close to the camera. So in this case, let's say this post has around, let's say, 1000 polygons, which would be okay in this size. Let's say it's 5 meters high or something like that. But the other posts are also rendered with 1000 polygons. So for each of these tiny small posts down there in the background, you have 1000 polygons adding up to your render. So that's pretty bad. So to save performance, we use the LOD system to give Unity, depending on the distance to the camera, different objects in different resolutions. So let's see that in action. So here we have 3 different LOD levels for the same mesh. Apart from the polygon reduction, it's important to notice that each LOD level should have the same silhouette. Because as the LOD levels transition between each other, the silhouette should not change, otherwise you'll notice the difference. So as you can see from all sides, it's pretty much the same silhouette, so that's no problem. Also, as you can see, it's the same textures, the same UV set, the same shader for all 3 levels. So second, how can we set it up? Let's quickly jump over into Unity. So what we have here is a scene from our currently in development game. And as you can see, we have this rock here, like you've seen before, and it's used quite often. So if we can create different LOD systems for this, it will increase our performance quite significantly. So we have our rock here in the hierarchy, and next we're going to locate the mesh in the project folder, which is here. You can see this little icon here. So we have one rock at the moment, which is in a prefab, and this prefab is placed throughout the scene. So at first we need at least 2 different levels of LODs. So what we do is we duplicate this, Control D, and create a rock 1 with this. So let's name it properly. Let's name this LOD 0 for the highest level, and let's name this LOD 1, for example. So now we have these 2 LOD levels, and we're now going to optimize one of them. So let's double click the LOD 1. So Blender opens up. I won't bore you with all the details of optimizing this mesh, but still we can have a quick look at how it works basically. So what we're trying to do is to optimize this mesh so it has around, let's say, half the polygon count, but still keep its UV layout, so we can use the same texture as we use on the high resolution mesh. So in Blender this is fairly simple. There are also algorithms for that, but I prefer this method because it gives you the most control. So what we do is we select the edges that we don't need anymore, or at the place where we want to optimize, press Alt-M, which is merge, and choose collapse. And what this does is it will collapse these edges together and save us, let's say, 5 faces, which are 10 triangles already. So as you can see here in the UV image editor, collapsing edges won't destroy the UV layout. So let's do it again so you can see it more clearly. Here we have the selected edges marked. If you haven't noticed, I activated this keep UV and edit mode mesh selection in sync mode. So what we select in the viewport is also selected in the UV image editor. So let's press Alt-M again, choose collapse, and as you can see, as the edges were collapsed on the mesh, the edges were also collapsed here in the UV editor. So if we continue this process all over the mesh and again and again and again, we will end up with 2 or 3 meshes depending on how many LOD levels you need, as you've seen in the beginning of the video. Okay, now, so here we are back again in Unity, and let's see how we can create a LOD powered object from our rocks. So if you follow the documentation, the LOD system works by adding a LOD component to an existing empty to the scene. So let's quickly do that. Create an empty into the scene, name it something meaningful like rock or whatever. Now we add a component rendering LOD group, which is what we're looking for. So as you can see, the LOD group was inserted here as a component, and what Unity now needs is different meshes for different LOD levels. So let's quickly do that. Search it in our project folder. I have prepared 3 levels, so let's quickly add them. Just drag and drop, just drag the LOD 0 onto the LOD 0 panel. Click yes, reparent. LOD 1 to LOD 1, yes, and LOD 2 to LOD 2, yes. Okay, so if you're doing it from scratch, that's pretty much it. You now have 3 meshes in 3 different LOD groups, and what you can do now, this is pretty handy. You can drag the camera here, and as you transition between the LOD levels, you can see it update into the scene view directly. So you can see here it switches between the both LOD levels. And now it's culled. So culling means, as you probably know, just disappearing. No rendering at all. So what's very cool about this system is that it does not just take into account the distance of the camera, but the size of the object relative to your screen. So these percentages here mean how many percent of the object is visible on screen. So as you can see, this is now, let's say, 60% of the height of the object, and this is 30%, and this is 10%. So this is pretty cool, because if you have objects like we have in our scene, which are placed many times but at different scale, you have this problem. If you just would take into account the distance of the camera, a very small rock would be in the same LOD level as one which would be, let's say, 10 times bigger, which would be wrong. So what Unity is doing is just calculates the size depending on screen pixels, which is very cool. So another cool feature here in the LOD system, let's pick the empty again, is apart from just watching it transition between the levels, you can change these as well. So what you can do now, let's say it's culled at 3% or 2%, and as you can see, as you drag the handles between the levels, it will also get the camera into exact this distance, so you can see exactly at which distance you want it to be culled. So let's say if the culling, for example, is at 20%, you will just note this popping. On the other hand, it's pretty performance effective, but it doesn't look very cool. So let's make it to 2 or 3%, so it's pretty much far away, so the viewer probably won't notice it. And now let's see how we can adjust these other LOD levels. Something like that is probably okay. So that's basically it. Another thing that you can do in case you only have 2 LOD levels or you have more, you can always insert or delete LOD levels. So let's say we only need 2 of them. We can just delete this LOD 1 group. It prompts us, yes we do. And now it has just deleted it in between them, and now we have only 2 LOD levels left. The same way you can always insert another one. So here just right click into these bars and just insert before, and now you get another LOD level which has no mesh at the moment, this LOD 1, and you can drag and drop another mesh into here. Now finally, let's have a closer look at how we can integrate this into an existing project. So let's switch over to Unity again. Probably many of you will have the same problem like we had here. You have your existing project and now Unity 3.5 is out and none of your meshes is LOD optimized because there was no LOD system before. So what you probably have in your scenes is a prefab. I just tried to redo the same situation like we had before. You have a prefab in your scene which just holds the mesh. So this is our test prefab, and you've placed it all around the scene, and what you want to do now is make all these models LOD optimized, but without replacing them in the entire scene, which would take forever. So the trick here is you have the prefab and the mesh directly below it, but what you need, like we've seen before, is an empty with a LOD group attached to it. So the trick is the prefab basically is an empty with a lot of components here. So the way we can transfer that is just drag the prefab into the scene or pick any of the prefabs you have and delete all the components it has. So remove the mesh filter, remove the mesh renderer, and everything's gone, and you're left with just an empty which has all the transformations still stored. This is what you probably want, like scale and position or rotation. And now you just redo the same procedure we did before. So just add component rendering LOD group and just do it the same way we did before. And if you then hit apply on your prefab, you will end up with all your meshes in the entire scene replaced with your new LOD 1. So that's basically the trick. So down here we can see how it all looks when it's done. So here you can see you have LOD 0, LOD 1, LOD 2, and at 2% it's just cult. And all the rocks here are the same prefab, so like we've seen before, we have a prefab with just the LOD group component attached and the meshes split into the LOD groups. And now here we go, the entire scene is just crowded by these rocks, and this all works pretty fine. Another little problem you may encounter is that if you drag the camera handle here, the LOD system will not update in the correct way. So it will switch to LOD 1, let's say, instead of 35% as it displays here at 50%. So the reason this is, it's in the preferences. So if you go to project settings quality, you have these levels, like you probably know, fast is fast, simple, good, beautiful, fantastic. And the highlighted one is the one the editor shows. So I'll show you this in a moment. Just click fantastic, and now you can see this changes the LOD bias. So now let's see where it switches. Here you can see the camera is definitely in the LOD 1 area, but still the scene view just shows LOD 0, which may look wrong, but isn't, because of the LOD bias. So if you want the exact representation of these values, just pick the good settings, because the good settings have, let's see, a LOD bias of 1, which will exactly represent the values you can see here. You can also read this up in the documentation. So the bias basically decides if the engine has to decide between two LOD levels, depending on your LOD bias or on your quality settings, it will just pick the higher or the lower one. So if you're playing on Fantastic, Unity will maintain the higher levels on a much bigger distance than if you play on Fastest. So just in case if you're wondering why these values don't correctly represent what's shown in your scene, that's the source of it. So that's basically it. See you next time.